Okay, and we're back talking about factoring common factors, and this time we've got sort of an interesting thing going on. Factoring by grouping is going to be our next topic, and before we get into that, we do need to still talk a little bit about common factors and the fact that a binomial can be a common factor. We do need to, again, straighten out the language a little bit. Remember, factors are part of an expression that are multiplied by other parts. So, for example, if I say 6x and 4x plus 3, right, we would say that the 6x and 4x plus 3 are factors. Okay? Well, that's all well and good, Professor Peebles. Now what? Well, terms are parts of an expression that are separated by addition and subtraction signs. Now, I recognize that within this quantity, 4x plus 3, there's an addition sign. But that doesn't make 4x and 3 different terms to 6x. 6x sees 4x plus 3 as one factor. But if we look at this part of the expression and this part of the expression, they're wholly separated by one subtraction sign. And so we could say that the quantity 6x times the quantity 4x plus 3 and 5 times the quantity 4x plus 3 are terms of the expression. Okay, so when keeping this straight, remember that we can look for common factors among terms. We don't look for common factors among factors, right? We have two terms right here. What is the common factor? Well, the answer to that is that 4x plus 3, the quantity 4x plus 3, is a common factor. How do we know? Well, it is multiplied as part or is a factor of part of each of the terms. So how would we treat it? In this case, the way we're going to treat it is just like we treated other factors in our previous examples, and that is to say that, well, 6x times whatever the common factor is minus 5 times that common factor is going to be equal to the quantity 4x plus 3 times, from the first part of the quantity, 6x. Notice that we would take 6x times the quantity 4x plus 3 to get 6x times 4x plus 3 minus 5. And in this case, we're picturing it this way. If we were to reverse the situation and multiply, we would see that 4x plus 3, the entire quantity, could be distributed one by one to each of those two terms if we reversed the process. So the factorization is 4x plus 3 times 6x minus 5. All right, let's try it again right here. This time we've got an example for a times the quantity b minus 7 plus b times the quantity b minus 7. In this particular case, we can see that b minus 7 is a common factor. If you're having trouble with seeing that, sometimes you can do a little bit of a replacement. The way I tend to think about these things is that a multiplied by something plus b multiplied by that same something, whatever the factor is, by the distributive property would be equal to whatever that quantity is times a plus b using the distributive property. Right? So whatever quantity this thing happens to be, it's the same for both. And so we take that common factor out. The only difference is that in this case, the quantity happens to be b minus 7. So b minus 7 would be the common factor multiplied by a plus b to give us a times b minus 7 plus b times b minus 7. All right, one more quick note right here, because we're going to use this a bit in our factoring by grouping, is the skill to factor out a negative from a pair of terms, even though negative did not exist before. So we might think to ourselves, well, if I factor out negative 1 from the quantity negative a plus 2b, what would I have to have? Well, I'd have to take negative 1 times positive a to give me negative a. And I'd have to have negative 1 times negative 2b to give me positive 2b. So you have to be careful with the way that you factor out negatives. Let's look at this second pair of terms. For all intents and purposes, even though we didn't put a plus in front of that 3, it is there. So if we're asking to factor a negative 1 from 3x minus 2y, we can think, well, negative 1 would have to be multiplied by what to give me positive 3x? And the answer is negative 3x, because negative 1 times negative 3 gives me positive 3. Negative 1 times what gives me negative 2y? The answer to that one is plus 2y. Right? Very simple procedure, but again, you have to remember what the negatives is. All right, let's take our negative 4a minus 3b. How about that one? Well, if I factor out negative 1, I can definitely see that negative 1 times 4a gives me negative 4a. And negative 1 times positive 3b gives me negative 3b. And you do want to keep the plus sign. Don't ignore it, right? Because otherwise you're saying that 4a would be multiplied by 3b. That's not the case at all. If it helps, you can always imagine this last one as being something more like negative 4a added to negative 3b. There's always an addition sign between our terms, even if there's a subtraction involved. All right? So that might be a helpful way of remembering this. Okay, more coming up in the next video.